This satellite was built by IDYM team members. You just see this one.
Okay. The children
Ask
can
the
ask
children
me
also to watch. Yeah.
The remaining two satellites, Pratham from IIT Bombay and PISat from PES University Bangalore, are from India. The main objective of Pratham is to estimate the total electron count, TEC, with a resolution of 1 kilometer by 1 kilometer.
Have a feel of the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, 2, 3, 4,
and ground
5,
upon ignited.
6,
Vehicle
7,
lift off normal.
8,
प्रक्षेपण जलन बिल्कुल सामान्य आकाश की ओर उठता हुआ PSLV और
Any moment now,
जोरदार
we will hear the confirmation of the separation of the Pratham satellite built by students of IIT Mumbai, and also followed just 10 seconds later the separation of PISat satellite built by the students of PES University Bangalore.
जी हाँ, वैसे कई उपग्रह इसरो भारतीय विश्वविद्यालयों के लिए छोड़ चुका है। जी हाँ, प्रथम उपग्रह भी अलग।
Pratham is separated.
So this was you can see the example I showed to the children, which was built by a team member of Igniting Dream of Young Mind Foundation. So dear children, never think that anything is impossible in this world. As your ma'am is very active, definitely you can make the change in your country, you know. And we want to teach you because you can see the challenges right now, what world is facing. You can see that if some country is strong, they are attacking on some country which is not strong. And people are getting displaced from one place to another place. So that is why we want to train the student that, yes, if you are a student, you can build rocket for your country. You can build satellite for your country. And if you can build in this age, definitely when the age will become 50 or 60, you can make something very big, and that will really help your nation. So we want that from you. This is what the output I want. We want from you. That's why we are trying every day. You must learn it. Okay, children. So I will show you another one video, which is the student who has built one rocket. And you, after seeing this, you will get inspired and you will understand that yes, I can also make this. 1 second. There is some technical problems are coming. Just wait for 1 minute. I will show you one video. Which is built by a very small girl from India.
You have great
1 second.
materials, great videos, very
Yeah, ma'am.
beautiful.
Yes, ma'am. Actually, I want the Romania student to make something. That is why we are trying now. Let's see if they can make something.
My name is
See the
Inara
small girl
Shashnavas.
who has built
I
the
am a
rocket.
student of
You can also
Mukundapuram
make that.
Public School, Thrissur District, Kerala State. My project is called a toy rocket. This is a best example of Newton's third law of motion, which states every action has an equal and opposite reaction. I made this rocket with the help of easily available low-cost materials. It takes about 1 hour to make this rocket. It's quite simple. I will now demonstrate the working of this model. This is a Diwali rocket. From this, we are going to make the engine for our toy rockets. We have to remove certain parts of the Diwali motor and make some modifications to get our toy rocket motor. Also remove any excess chemicals that spill out. We now have to cut, shape and fix a balsa cap to the open end of the Diwali motor. Sand the sides of the motor to get a clean finish. Now the rocket motor is ready. It's very simple to make. The rocket motor has to be pushed inside the body of the rocket and fixed tightly with the help of glue. Now I am going to attach the fin to the body of the rocket. The fin can be made out of plastic, corex, cardboard or balsa wood. These are the tools and materials that I have used to make my toy rocket. Now our rocket is ready to be launched. There are some safety instructions that has to be followed while launching a rocket. These safety instructions are very important. The first thing is there should be a large ground and zero wind. You have to make sure that there are no electrical lines or any VIPs passing by. We have to make sure to launch the rocket vertically, and when it comes back, we have to make sure that there is no flame around the motor area or on the fins. Before we launch the rocket, we have to make sure that the nose cone is vertical and the fin should not be shaking, and the motor has to be fixed inside the body strongly. This is the electrical circuit needed to launch my toy rocket. Now I am going to connect the nichrome wire to the circuit. This is a launch mechanism. This is a 12-volt battery and this is the switch. I worked on this competition project for 5 days. During this period, I tried various rocket designs from simple to complicated. After many trial launches, I have finally made a rocket out of PVC pipe that is simple, safe and great fun to make, and launch it into the blue sky. I have named this rocket Inara as it means shining light. I'm sure that all the boys and girls would love to design, build and fly a toy rocket. I would be happy to answer any questions that you may have. Before I say a goodbye, I would like to wish all the participants of the very best of luck. Jai Hind.
See, dear children, you can also make like this.
Applause, yeah.
That is why I was showing you the video. She is the member of the foundation and see how she has built the rocket. I want the student from Romania also to make similar rocket like this. And we will help you. We will help you in this. There is nothing to worry. We will even train you that how we have to start and how we have to achieve this target. Since you are in Romania and we are in India, very far distance, but we love to see if the student of Romania can make something like this. You see a small girl, she is only 13 to 14-year-old, and she made a rocket, it went very high, right? So you can also make that. That was the main purpose of conducting this program. We want you to become a scientist. We want you to become a junior scientist. You make something for your country. Let your country become superpower. Let Romania lead the world. That was the main purpose of asking ma'am, please, we want to start one program in your school. And ma'am was very, when she came to know that this program is very good, she immediately replied to us and she told, yes, we want to teach to our students because this is very useful. So that type of passion, that type of energy you should have. This was something which you saw that is a small rocket. Even you can build a satellite and it can be launched with the help of balloon. You might have seen the hydrogen balloons, right? You can launch with the hydrogen balloons or you can launch with the drones. You might have seen the drones also for this thing. And you can also launch the same satellite. If you say, if you can do some modification, you can launch with the help of NASA rockets, ISRO rockets. That is also possible. As you see one video I showed to all of you, that one satellite was moving into space with PSLV rocket. That was built by our team members. So dear children, nothing is impossible. If we will think, we will do anything in this world. And you can do it.
Nu aveți moace plictisite și chicate în...
Yeah. Please, ma'am. Now, Hemanji, please continue. Hemanji.
Yes, thank you very much. Very
Yes,
interesting material.
yes. Just 2 minutes. Just 2 minutes. Just 2 minutes. Okay, so I was talking about geosynchronous satellite, and I was saying that there is a basic difference between a geosynchronous and geostationary. I hope everyone was able to hear me, right?
Yes, please.
Okay, so I was just showing that Earth is not perpendicular like this. Earth is tilted at 23 degree. Now do one thing is concentrate on any one of the letter. Say you are concentrating on G. Now this Earth is tilted like this. Now when I'm rotating this like this, so what has happened is it has come up as compared to in this position. So if you take some horizontal reference, what happens is after one rotation, the same letter G, which was a little bit down, has come a little bit up. So this is what happens with all the countries which are on the above or below the equator. Okay, so Earth is tilted something like this. So when it rotates, so one which was down, it comes like this up. So the relative position of the country is changing when it is revolving. So if I want to maintain it, I will call it as geosynchronous satellite. But for the equator, the height doesn't change. So if the satellite is moving above the equator, it is called as geostationary. And if it is moving above or below the equator, then it is called as geosynchronous. So there is this basic difference between the two words, and understanding that is also very important. Okay. So next, coming into that only. So if you just saw over there, there were some 24 odd satellites which I showed you in the MEO one. Okay. And now if you see in the GEO one, I'm just showing only the 3 satellites. So what is the basic reason for that? So if you just try to understand, the MEO was somewhere at about 15,000 to 12,000 kilometers from the Earth's surface, whereas a geosynchronous satellite is about more than 35,000 kilometers from the Earth's surface. So just take an example of the town where you live. So if you stand on the terrace of a 4-floored building, you will be able to see your entire locality. If you go on the top of the terrace of a building, which is a 10-floored one, okay? And now if you stand and see, you will be able to see their entire town. And now if you go on the 25th floor, okay, and stand on the terrace of that and observe, you will be able to see not only the entire town, but the other towns which are there in vicinity. So what I mean to say over here is, as you go above and above the Earth's surface, the visibility or the region goes on increasing. Okay, so the visible region goes on increasing. So now this is at a very high distance, at somewhere about 35,000 kilometers, whereas the satellites in the MEO orbit, okay, those are at 12,000 kilometers. So what obviously the field of vision okay, which I have drawn over here. You can see something like this. The cone I have drawn. This is the field of vision. So that much area of the globe, this particular satellite can cover. So if I want to cover the entire Earth at one go, I need this, and this. 3 satellites I require. Okay. I require how many satellites? I require 3 satellites. And that is why I've shown over here 3 satellites. Similarly, if you go over here, okay, in the MEO one, and if I draw the field of vision, again, if I draw a cone over here, let me take this satellite, any one of the satellite, and let me draw a cone. So see, the field of vision is limited. Our field of vision is smaller. And if you just compare here, the field of vision is more. And therefore, if I want to cover the entire globe at any given moment and the MEO orbit, I will require more number of satellites. And therefore, I have written over there, a typical GPS system in general requires 24 satellites. And here, for geosynchronous, you require only maximum 3 satellites. By 3 satellites, you'll be able to cover the entire Earth. Now, the use. What is the use of the satellites which are there in the GEO orbit? We have seen of the LEO orbit also. We have seen of the MEO orbit also. Now, what is the use? Broadcasting. So basically, what now we are doing is a broadcasting. Okay, we are doing broadcasting over here. So everything is happening in the same time, almost at the same time of instant. I'm speaking over here in a country called as India, okay, and somewhere in the southern part of this country, and you guys are there in Romania, which is very much far from India, and I'm speaking over here now, and you are able to hear me at the same time instant over there. How come it's possible? This is what we call it as broadcasting. But how come it's so fast? So what happens is, what is happening right now when I'm using an internet, okay, with my mobile, my laptop, my internet connection over here is sending out electromagnetic waves, okay, and then those electromagnetic waves are sent from the Earth, okay. I'm right now at this part of the globe, from here till here, okay. Then, and suppose there is a person who is sitting in America over here, he'll be also able to hear at the same time instant. From here, this signal will be transmitted to this particular satellite. Then this satellite will transmit the signal to this satellite, and finally this satellite will transmit the signal, okay, to the person sitting in this country. Now, the main question is, how is it happening in the real time? And that is where I said electromagnetic waves. So what does this electromagnetic waves travel at the speed of the light? What is speed of light? 3 lakh kilometers per second. How many kilometers the light can travel in 1 second? 3 lakh kilometers. Okay. So these are in the GEO orbit. So from year to year, we know this is somewhere around 35,000 kilometers. Again, this 35,000 kilometers. Okay, then this somewhere 50,000 kilometers, this 50,000 kilometers. Even if you add all these distances, still it's less than 3 lakh kilometers. Okay, this is 1 lakh kilometers and this is 70,000 kilometers. So still the signals have to travel only 1,70,000 kilometers, whereas the light is traveling at the speed of 3 lakh kilometers per second, and the electromagnetic waves are also traveling at the speed of the light. So how much distance it can cover in 1 second? Okay, how much distance? 3 lakh kilometers. And but obviously this distance is less, okay, than the distance which is required to travel. And that is why this is happening at the same time instant. Okay, so we see live matches, we see live performances. Now we are seeing I am live over here and you are hearing me live over there. So that is what the broadcasting. So the satellites, Okay, these satellites are used for the broadcasting purpose. Now, let's move ahead and let us see one more type of orbit. So basically, when I started, I said 3 orbits. Apart from there are the other orbits also. Let's see the next type of orbit, which is highly elliptical orbit. So what is an highly elliptical orbit? So let us try to understand. We were talking about circles. Now, if you press the circle little bit, so the shape which you get is a elliptical. So just you can remember like a rugby ball. Okay. So that rugby ball is like having little bit of elliptical shape. So now this satellite, instead of moving in the circular path, is going to move in that particular shape. Hence, we are calling it as highly elliptical orbit. Now, what does this basically? So let us try to understand the countries like, okay, which are very much near to the North Pole, okay, and the South Pole, but Antarctica is there, no one lives over there, okay, and Australia and New Zealand are nowhere near to very much South Pole. But when we talk about, okay, Russia, Alaska, Canada, then Iceland, Norway, these are the countries which are very much near to the North Pole. So their weather is affected by the amount of ice which is forming. Okay, if the ice deposition is increasing or if the ice is melting, okay, it is going to decide their weather conditions because they are very much near to the North Pole. So if they want to predict their weather properly and accurately, they require the satellite to be more near the North Pole for the larger amount of time. Okay, and that is why they choose this path. If you just remember, if it is a polar synchronous, it was going very fast. If it's going very fast, it is going to spend very less amount of time near the North Pole, and because of that, it will not be able to see how much amount of ice is there, how much amount of ice is melting, and so on. That is why these countries want that the satellite should be at most of its journey throughout its orbit should be near the North Pole, and that is why this path is chosen. So you can see here, when it is going from this part to this path, its entire most of the journey is always above the North Pole. Okay, so this is the highly elliptical orbit. Next, now we are going to a little bit more complex part. Okay, so it's not how we perceive the world. Why I'm saying like this? Because when we see the rockets are launched, we see it going vertically upwards, but it will always not go vertically upwards. Okay, after certain amount of height it reaches, okay, it is turned horizontally and then it starts moving in the circles. So this is the path which I'm showing over here. The rocket is launched from, say, this part of the earth, and then it follows this yellow trajectory, and then slowly we are changing the direction of the rocket, and finally the rocket becomes horizontal, and now it is going to move around the earth in the circles. Okay, so let us try to understand this geo transfer orbit. So not only geo, where I'm just teaching you first transfer orbit, and then we'll go to the geo transfer orbit. So now we saw some 3-4 different types of orbits: LEO orbit, MEO orbit, geo orbit, and highly elliptical orbit, right? So if I want to go from one orbit to another orbit, this International Space Station is in the LEO orbit. Okay, it is somewhere around 440 kilometers from the Earth's surface. So we keep on talking about International Space Station. So where is it? It is in the LEO orbit. So suppose from the LEO orbit I want to go in the MEO orbit, or from the MEO orbit I want to go into the GEO orbit. So for a particular time moment only, I'll go to some other path, and that is called as the transfer path. In this case, this yellow one, okay, if I'm revolving in the yellow one, then it is the Leo path. But I want to go in the geo orbit. So for a certain amount of time, it is the satellite is going to go in this blue line. And then it will always revolve in this red circle. Okay. So only for a certain amount of time period, it was revolving in this, which is called as the temporary orbit. This is what we call here it as the transfer orbit. In this case, it is going in the geostationary orbit, hence the name is given as geo transfer orbit. Now, if you see, I have shown you dotted lines. So what these dotted lines mean over here is, suppose if the satellite is not able to revolve in this red circle, then it will revolve in the blue circle. So how it will go from, okay, this blue to red, we'll see in the animation. We provide an extra velocity to that satellite. Okay, we give an extra velocity. So when we give exactly at this particular point, we give an extra velocity, it will go in the red circle. Suppose if I'm not giving that extra velocity at exactly at this particular point, then it will revolve in the blue circle. Hence, I've shown this as dotted. Okay. So now let us try to understand the trajectory. So in India, we have our space organization, which we call it as ISRO. And they have launched many projects. So one of the recent one I'm going to explain you over here is about Chandrayaan path. Everyone in the world knows that Chandrayaan 1, Chandrayaan 2 became really famous. Okay, so I'm going to just show you the path of Chandrayaan. Okay, let us try to understand. So at this point, I have launched the rocket, and it will come vertically up till certain point, and then exactly at this point, which I have shown over there, injection to the Earth parking orbit or the parking orbit at this particular point, okay, which I'm showing you by the red color. Exactly at this particular point, it will become horizontal and it will start revolving around the Earth. Okay, the satellite will start revolving around the Earth. Now, exactly whenever the satellite comes at this particular red spot, I will give it an extra velocity, which we call it as boosting, which will just boost the rocket. So the moment I give the extra velocity, okay, from this first, it will go into this second. Okay. Then again, when it is revolving this second path, again it comes at this point. Again, I will give an extra velocity, because of which now it will go into this third orbit. Then it will keep revolving in the third orbit. Then again, when it comes at this particular point, again, I will give that extra velocity. Because of that, it will now go into this fourth orbit. Then it will start revolving this fourth one. Again, it comes at this injection point. Again, I'm going to give an extra velocity. And then it is going to go in this fifth path. Okay. Then it is going to revolve in this fifth path. Again, when it reaches at that injection point, again, I'm going to give that extra bit of velocity. And now my satellite is going to go in this particular path. Okay, which we call it as lunar transfer trajectory.
हेमंत जी 10 मिनट और मीटिंग चलेगा.
ओके ओके ठीक है, मैं इतना उनको एक्सप्लेन कर देता हूँ.
हाँ ठीक है,
10 मिनट
थोड़ा
में
सा कुछ
इतना हो
और बता
जाएगा.
दीजिए. नॉर्मल चीज बता दीजिए.
हाँ 10 मिनट में ही हो जाएगा. एक एनिमेशन बता देता हूँ. So I hope you have understood this. Then it will continue into this, and exactly at this point, we are going to change its direction and give a velocity in this direction. Then it is going to enter into the moon's gravitational field. Now it is very much near to the moon and very much away from the Earth. So the moon is going to apply its gravity on this satellite, and it is going to revolve around the moon. So this is the path of Chandrayaan. If you understood, it's okay. Otherwise, don't worry. I'm just going to show you one more animation. Okay, it will be clear to you. So this is launching of our rocket. Okay, Chandrayaan 2. So now, one after the other, the stages of the rocket will get separated. Okay. And as the stages of the rocket get separated, what happened? Just give me a moment. So you can observe here the satellite is getting separated from the rocket, and the trajectory which I was explaining you is there in this animation. You will understand it. Okay, via this animation. If you have not understood over there, no need to worry. Just observe this animation carefully. So now every time when it comes at this particular point over there, okay, see due to extra speed, it has went into the second path. Now every time when the satellite is coming over there, we are giving it an extra speed. This is what I was explaining you. Now it is going into the lunar transfer orbit from here. Okay, I hope the things are a little bit clear to you. So the three objectives we have completed when we started today. The objectives were what is satellite, why do satellite revolve, and that also circular path. And the third was which kinds of orbits. So we have studied all the orbits in detail, and this is the last part of the thing. Okay, components of satellite. I'll go very fast because we have lack of time, as sir has instructed me. We have less time, so I'll go very fast to this. So suppose if you want to make your own satellite, which a few moments back our founders were talking about, this is what you require. Okay, the first one which you require and the most important one is the transponder. Like the CPU is the heart of the computer, similarly the transponder is the heart of the satellite. Okay, what are its function? Change the frequency, remove the noise, and amplify the signal. Let us try to understand what is frequency. So if I'm talking, your teacher is talking, or our founder sir is talking, or any one of the student is talking over there, you'll be able to recognize their voice. And this is only due to each and every one is talking at different frequency. So suppose I'm sending information from the earth, and there's different informations. I want to categorize this different informations. Okay, then those can be categorized via frequency, and that is why change in the frequency. Next, remove the noise. So when I'm sending the signals from the earth, okay, a lot of other sounds also get added to it. Okay, a lot of honking of the vehicles will be there, chirpings of the birds will be there, some aeroplanes will be flying in the sky, that sound gets added. Okay, somewhere industrial work will be going on, all those things get added. But this is not what which we intended to send over there. So any unwanted signal is called as a noise. It's not that loud sound is called as a noise. Suppose I'm taking a session and someone else starts talking over there. Okay, then also it will be called as a noise. So second is to remove the noise. Okay, and the third, is to amplify the signal. So now, as okay, as the signal is traveling, and we saw it is at a very high distance from the earth, what is going to happen is the signal is going to lose its energy. So when it reaches over there, it will not be able to give the required information. So what the transponder will do, it will amplify the signal, which means it is going to increase the strength of the signal. Okay. So once it increases the strength of the signal will do the required work for which it was sent for. That is the transponder. Okay, just give me a moment. My laptop has just got shut down. Just give me a moment.
Yes, ma'am. So it was good, right?
Oh, wow, wonderful. Applause there.
I think please show the student, ma'am. We want to see the student and we want to, possible, please turn the camera to the student side.
I'm going to turn the camera now to
Yes,
the students.
children. So how you are feeling now? Are you feeling Josh? How is your Josh now? Very great. Very nice. Very nice, children. Very great. We really love the people of Romania. We are very far from each other, but we love all of you. And you all will get certificate from IDYM.
Thank you very much. And if you are permitting us, we have a little surprise for you. One of our students wants to sing a song for you. Can
Yeah,
you wait?
ma'am, please, please.
Yes,
Please, ma'am, please.
yes, Papa Jono. She will not.